Hi again. Today I will talk about how to diagnose charge problem on iPhone 8, 8 Plus, iPhone X, XS Max, and XR. As the charge circuit is different uh, than iPhone 7 or iPhone 6, and I will introduce a new tool for checking circuit. That's very important to use instead of oscilloscope. If you find that oscilloscope is difficult to use, we will use this tool, which is a logic probe for checking especially signal lines, and we will use today especially for checking switching on charge coil to check if the charge IC is good or not good, if the charge coil is good or not good. So first of all, we have to understand how the charge circuit on iPhone 8, 8 Plus, X and X Max and XR, how it's work before we trying to check on the board and diagnose the problem. First of all, to understand charge circuit, we go on the dog-flex connector. Dog-flex connector. Looking for the important lines for a charge circuit. First line is this Hydra connect detect L. This line is important in charging circuit. When you connect the charge cable, the Hydra, which is the USB IC, detect if the cable is connected to the phone. This line, this is a signal line, like a signal line. Its mean detect L low. When detect the cable, when Hydra or USB IC detect the cable, this line is go low. So how we check this line? We'll check with logic probe and see if it's like this line, how it's go low or high. Second line, important for charging circuit, is the PP bus, which is the main charging voltage, 5 volt. So the other lines or important lines on the connector is Hydra ACC1, which means Hydra accessory 1 and accessory 2. This lines is for detecting the type of accessory which is connected to the iPhone. One of them is used when you put the cable in one direction, and when you reverse that cable direction, the other line working as a data line with the chip inside the accessory or the cable, charge cable. There is a chip inside the cable. Using these lines, Hydra USB IC, detecting the type of accessory connected to the phone. Other lines important in charging, which is Hydra data line, which is USB data line, DP1 and DP2, positive and negative. This is important because Hydra USB IC using the values on these lines to understand how much this charger ampere is the maximum charge. You know, sometimes the charge is 1 ampere, other charger is half ampere. So these lines are important for this function. This is all about the connector. So we go for the IC and try to understand how it's working. So first of all, as we understand before, the connect detect line must go low when you connect the charge cable. So on this resistor, the other side of the resistor is going to Hydra USB IC. When you connect the cable, the state of this line is going low, as we will check on the logic probe. The second is the 5 volt PPV pulse. 5 volt is going first. So let's check what it's going for. This is all capacitors. The other side, it's go for this chip, which is the main charge IC in iPhone X, XS, and XS Max. It's called Yangtze or something like this, I don't know. Charging IC or charger IC. So this is the PP main charge voltage, 5 volt, coming first to this chip. This chip check the 5 volt, if it's good or not good, it's safe or not safe. If it's safe, it send a signal, which is, if it's safe, it send this signal, this line being active, which is power positive variable USB RVB. RVB mean the reverse voltage protection. Reverse voltage protection. This means that this 5 volt is protected. So let's check this line where we go. Let's go for this chip, which is a Type C fast charge chip, and going to Hydra, which is the USB IC. When this voltage is coming to Hydra, which is 5 voltage, Hydra, you sending a important signal, which is Hydra to Yangtze V bus valid, meaning that the voltage coming from charge cable is valid. It's this type of signal is low. So if this line going low when you put the charging cable, so the voltage is good, and 0.5% the Hydra is good, no problem. 50%, pardon, 50% Tigris is good. So we will check this line. Let's go there. Is go back to charger, main charging IC. If this signal is coming and it's valid, 0 volt, low, and we will check now. Charging IC using the 5 volt coming from charging cable, and starting to buck switch this voltage, this voltage to 4.2 voltage, which is go to VDD main, to power on the phone, to make a supply for all IC like power IC and other ICs in phone, to power on the phone, only to promote phone to power on, not for charging. So this is a buck switch circuit, consists of the main chip IC, main charging IC, and a buck switch coils, these 4 coils for iPhone XS Max, like, and this bootstrapping capacitors. This is important in buck switch circuit. To check if this circuit, buck switch circuit, is working or not working, we will check if we have VDD main, 4.2 voltage on VDD main, after connecting the charger without battery. And we can check also if the problem with buck switch circuit with the IC itself or with these capacitors or these coils, using a logic probe to check the switching state of these lines. So basically, now we have a 4.2 VDD main after connecting the charge cable, but still the phone is not charging. There is many steps to start charging. It must CPU and main PMU, power IC, and Hydra talk each together to collect information about battery state, battery temperature, battery information, how much the amperage of the charging cable we connect. So till now, we can check on the CPU, can check on the battery state. This is the battery connector on iPhone XS Max. As we can see, this is the PP BAT VCC, the main voltage for the battery, and this is the ground pin. And we have 2 lines, which is I2C0 SMC to gas gauge serial clock, I2C0 SMC bidirectional gas gauge SDA. These lines CPU use to talk to the battery, to inform for the state of the battery. If this line is not good, charging will stop, and you will see many see a problem with the battery percent on the iPhone itself. These lines connected to MOSFET, which is important. These MOSFETs for power level shifting, logic shifting, gas gauge I2C level translator, it's called, because the voltage here is different than the I2C voltage, working voltage, which is 1.8 voltage. So they use this MOSFET as a logic level translator. If this from the battery itself, the signal on the serial clock here come 2 voltage, like, or 3 voltage, using this MOSFET is go on the other side 1.2 voltage as same pulse, at same signal. That's the important thing. So this MOSFET is near the battery connectors, and many problems we have with this MOSFET, as we can check here. Many it's glue, so with temperature it's disconnected. It's just disconnected and making the problem of charging problem. And this the battery temperature resistor we mentioned before, as we can see here. This is the battery NTC, battery temperature resistor, which is this resistor, and this capacitor. This is important because it's make a problem in charging, like fake charging maybe. So let's back to board and try to test the charging circuit in iPhone XS Max. So we start with, as mentioned before, with the main charging connector, main charging connector. So first of all, we check the state of Hydra connect detect line, which is very important. If we have a problem with this resistor, we got no charging at all. So this is, we will connect the cable without a battery, no problem, without a battery. And now we will using the charging, we will using this tool, which is the logic probe tool for checking signals like this. This tool is simple as it's, you see the lid on the tool itself, it's glowing. If the line is low, it's go low. The lid is going low like this. We put on the ground like this, and if the line is high, it's giving uh, glowing the lid. So we will check the connect detect. Connect detect is coming on this resistor. As you can see, the line is low now, so we understand that the line is good. Detect line is good. After that, we will check the 5 voltage V bus. First of all, let's go to main charging IC, on this resistor, capacitor, I don't know, we will check on the board. We can check here, so we showing the voltage. We can check as a voltage. I remember here. We can see 5 voltage here. That's good. Now we have to check if the charging IC, out the voltage on the RVB line, which is on A3 pin, RVB line. So this is the RVB line. We can find a component to check maybe. Yeah, on the other side near the Hydra USB, maybe like this. Let's remember where it's 1, 2, 3, 4. 1, 2, 3, 4. We must have 5 voltage here. As we can see, just a minute. Let's close this. And finish this signal, which is important in repairing iPhone. So we have here 5 voltage, good. So that maybe 50% the integrity is good. Now we go for the Hydra, which is USB, must give this signal Hydra to Yangi's VBus valid on H3 pin, which is this line. We can check here on this probe point. If it's good, this probe point, if you see, if it's good, we will find a low, because this signal must go low if the Hydra is good. So let's check like this, because the space is tight. Let's check like this. So it's low, so it's good. If we find it this high, then the Hydra is not good. The USB charger is not good, must replace. Of course, if we check before that the 5 voltage is coming correctly to this chip. Okay. After that, let's check again what we have now. Charging IC must switching using 5 voltage here and using a buck switch circuit inside the chip with the bootstrapping capacitors and the coils to buck switching the voltage from 5 volt to 4.2 volt and sending to VDD main. As we can see in iPhone X Max, XS Max, we have 2 lines for switching, which is switching 1, buck switching 1, and buck switching 2. As I understand, the buck switch 1 is using on the normal charging. I think the other switching 2 circuit is working on the fast charge. Now we will check. We will see that the buck switch 1 line is switching normally, but the buck switch 2 is not switching, as it's not fast charging maybe. We will check how to check that. We will check on this capacitor, which is this capacitor on the board. We will check this side, LX side, switching side. And we can see now if the charging IC is switching or not switching. So this and checking this side and showing how the logic probe giving the switching for this line or not good. On this side must give switching. As we can see, it's a switching now. So the tagless or the main charging IC switching on this line. Of charging. So let's check the other switching line, if it's working or not working, which is must checked on this capacitor, on this side, this capacitor. Now we check here if we got switching or not, or no. As we can see, it's only high, not switching, but this line is switching. So we understand now that this chip is switching if we don't have 4.2 voltage on the VDD main. The coil connected to this switching line is not good. We have to replace it, which is this coil, and the other coil is this coil. 2 coils. Every line is 2 coils. Now, this is the pre-test for charging circuit in iPhone X, iPhone XS Max, iPhone 8, 8 Plus, all the same. Important to understand for checking the problem if it's Hydra USB IC or if it's the problem in the main charging IC or the problem in the coils, on the coils or these bootstrapping capacitor, which is very important in charging. After that, we have to connect the battery and check if the battery state information is good to make sure that this line is good. This line is good, which is the I2C line for gas gauge going to CPU. Most of technician when found a problem on these MOSFETs, they just shorted them, shorted like pin number 1 with pin number 2 with pin number 3, like this. 2 and 3 making a short here for a jumper, but that's not good. In iPhone 8, 8 Plus, X, XS Max, this line is going directly to CPU. If we have a problem when putting the battery, maybe a voltage from battery going going in this line, so they make a diode zener for protecting for over voltage, but maybe going to or reverse voltage, going to CPU and making a persistent fault. That's not good. So try to replace them, not to make a jumper on this MOSFET. This capacitor is important. The Hydra itself, after checking on the Hydra USB lines, DB1 or DB2, checking the voltage on these lines, understand how much the charger is the maximum ampere, maybe half ampere, maybe 1 ampere, and then give the information for this on this line, which is the Hydra to PMU USB brick ID. So this line is important. This capacitor is important. If have a problem with this capacitor, you always have only half ampere charging only on the USB or laptop, and the phone only charging maybe when it's turned off only. So make sure this line is good. That's all for this video. I'm trying not to make the video very long. I'm trying just to make a brief or in short how the circuit is working and how we diagnose the problems, and trying to introducing a new checking tool or diagnostic tool in every video. Like the video before, we talking about the CPU boot serial cable chip, and in this video we introduce the logic probe, as it's very old in electronic, but it's useful in checking in our iPhone diagnostic and repair. Okay, see you in the next video.